We can start with the second chapter, that is instruction set and programming in 8085. This chapter is very important for your board points of view. All the 6 programs in your paper comes from this chapter only. Okay, so students, this chapter is of 43 marks with all the options. So there are different number of instructions that we can study in this chapter, and you have to get a clear idea how we can apply these instructions in the program. Okay, so we can start with the first topic of this chapter, that is what is instruction. So what is instruction? Instruction is a bit pattern to perform a specific function. So instruction means a bit pattern to perform a specific operation by a microprocessor is known as a instruction. Now instruction is of divided into 2 parts. First part is the opcode part, while second part is the operand part. So that means instruction contains 2 things. First one is the opcode and second one is the operand. Now opcode means it tells or it specifies the type of operation to be performed. Okay, and operand is the data where we have to apply the operation. Okay, we have 2 things. First one is the operation and second one is the data. So operation means what we have to apply, and data where we have to apply. So opcode specify the type of operation, while operand is the data where we have to apply operation. Okay, so operand is the data where we have to apply the operation. Now students, in 8085, here in case of operand, we can specify the operand as a 8-bit data. Okay, whether 8-bit data is there in case of operand, whether there is a 16-bit data or a 16-bit address is present in case of operand, or we can say there are the registers that are present as an operand, or we can say any memory location that is present as a operand. So that depends upon the different types of addressing mode that we can study later. Okay, so operand is either 8-bit data, it is a 16-bit data, or the address, it is a register, any of the general purpose registers, that is A, B, C, D, E, H and L, and any memory location that is pointed by the HL pair. Okay, for example, we have example, suppose we have an instruction LXI B, 2000H. So in this instruction you can see this is the opcode while this is the operand. Okay, so this is the opcode and this is the operand, and this operand is the 16-bit data. So this instruction means we can load the BC pair with this 16-bit data. So this is a 16-bit data that we can load into the BC pair. Now why we are talking about the BC pair? Because here B is only written. So how I am telling you that this is a BC pair? Because if in any of the instruction X is given, that means we are talking about the pair. So in 8085 we have 3 pairs. First is BC pair, HL pair and DE pair. So if any of the instruction contains X, that means we are not talking about a single register. We are always talking about the pair. For example, we have an instruction in 8085 that is STAXB. So this instruction means we are talking about the BC pair. Okay, because X is in the instruction. Next instruction we have, suppose LDAXD. So this instruction again means we are talking about the DE pair because X is given in the instruction. So wherever in any of the instruction X is given, that means we are talking about the pairs. Okay, so in this case we can load the 16-bit data into the BC pair. Okay, why we can load the 16-bit data? Why? Because B is of 8-bit and C is also of 8-bit. So combined, when we can combine B and C together, then it becomes the 16-bit. So that means we can load the 16-bit data into the pair, but we cannot load the 16-bit data into a single register because the single register is of 8-bit only. Okay, now we can see the second example. Second example, suppose we have ADI05H. Okay, so this instruction means we can add the contents of accumulator with the data that is given in the instruction, and after that the result is again stored into the accumulator. Okay, so here in this instruction you can see this is the opcode that can tell which operation is to be performed, and this is the data where we have to apply the operation. So that means we have to perform the add operation, and with what we have to apply the add operation? With this data. Okay, so the data that is present in the instruction with the data that is present in the accumulator. So here this is the opcode and this is the operand. We can see another example. Suppose we have an instruction add B. So this instruction means we have to add the contents of accumulator with the contents of B register, and the result is again stored into A. Okay, so here in this instruction you can see add is a opcode. Okay, and B is also considered as a opcode, and in this B register the operand is present. So I will tell you previously, either the data is a 8-bit data, either it is a 16-bit data, or the address, either it is a register or it is a memory location. So if we are talking about this example, so here the data is stored in the register. So that means the data that is present in this register will be added with the contents of the accumulator, and the result is again stored in the accumulator. Okay, next example, suppose we have is SUBM. So here in this case this is the opcode which will tell the subtract operation will be performed, but with what? With the accumulator contents and with the contents of the memory location that is pointed by this M. Okay, so here in this example M is a location where data is stored. So we can say the operand is stored in this memory location, while this is the opcode which will tell us which operation we have to perform with the contents of the memory location and with the contents of the accumulator. Okay, so this is the opcode as well as the operand. Now students, after this next we have is the instruction word size. So in 8085 we have different instructions with different sizes. Okay, so maximum size of the instruction in case of 8085 is 3 byte. So we have a 1 byte instruction, we have a 2 byte instruction, and we have a 3 byte instruction that we can study now. So word size or the instructions we can divide according to its length. Okay, so according to the length of the instruction we have 3 different types. First type is 1 byte instructions, second is 2 byte instructions, and third one is the 3 byte instruction. So in 8085 all the instructions are categorized into 3 parts according to the length of the instruction: 1 byte, 2 byte, as well as the 3 byte instruction. Now 1 byte instruction. 1 byte instruction require one memory location. Okay, only one memory location will be required in order to store the instruction of 1 byte. Okay, so it will require only one memory location to store the instruction. So here we have only operand is there, and here we have only opcode. So the data or the operand is also inside the opcode only. So in this case there is no operand. Okay, the operand is stored within the opcode only. For example, we have move B, comma C. So that means whatever contents are present in this C register will be shifted into the B register or will be copied into the B register. So here the data is stored within the registers only. The data is not specified in the instruction, that is stored in the register. So that means in this opcode, the operand is present inside. Okay, next we can see example add B. So in this instruction again we can see the operand is not specified individually. The operand is present in this register and this is a opcode. Got it? In next instruction we can see CMA. This is complement the accumulator. So in this case again you can see the data and the 16-bit address or the 16-bit data is not specified individually in these type of instructions. The data is present in the opcode itself. Okay, so these type of instructions are known as a 1-byte instruction. So in short, the 1-byte instructions are the instructions where the 8-bit data or the 16-bit data or the 16-bit address is not specified explicitly. That is implicitly present within the opcode only. Okay. So likewise, in this instruction, the data is present in this register only, and here the data is present in the accumulator where we have to complement. Okay, next instruction we have is RAR. So that means rotate the contents of the accumulator by right on the right side carry. Okay, so again in this instruction the contents are present in the accumulator. So this is the opcode and within the opcode operand is present. So these type of instructions are the 1-byte instructions. Now after this, students, next type of instruction is the 2-byte instruction. So in case of the 2-byte instruction, it can require the 2 memory locations. Okay, 2 memory locations are required to store the 2-byte instruction. First memory location is used to store the opcode, while second memory location is used to store the operand. Okay, so 1 byte is used to store the opcode while 1 byte is used to store the operand. So in short, these type of instructions are of 2 byte. So students, in this case, basically the operand is 8-bit data. Okay, so this 8-bit data can occupy 1 byte of memory and this opcode can occupy 1 byte of memory. Likewise, in this example, all the opcodes can only occupy 1 byte of memory. But if we can specify the data or the address in the instruction, then those instructions will be either of 2 bytes or either it is of 3 bytes. Okay, so these instructions can use 2 successive memory locations. So first is used to store the opcode while second is used to store the operand. Now we can see the example. For example, MVI B, 57H. So in this instruction you can see MVI B is the opcode that, okay, and 57 is the data. So that this instruction means we can move the contents that are present in the instruction immediately into the B register. So the instructions where the 8-bit data is specified, those instructions are of 2 byte size. Okay, so 1 byte is used to store this data, that is 8-bit data, and 1 byte is used to store the opcode. Second example we can see XRI C, 05H. So this instruction means XOR the contents present in this instruction with the contents that are stored in this register. Okay, so sorry, XRI 05H. So this instruction means we can XOR the contents that are present in the instruction with the contents of the accumulator, and finally the result is stored in the accumulator itself. Okay, next is next example we can see SUI 44H. So this instruction means we can subtract the contents immediately that are present here in this instruction, that is 44H, with the contents that are present in the accumulator, and the result is stored in accumulator. So in these 2 examples, this is the opcode while 0, 5 and 44 is the data. So this data can use this data is 8-bit, while this is also of 8-bit. So that means 1 byte is used to store the opcode and 1 byte is used to store the operand. So these type of instruction comes under the 2-byte category. Now third type is the 3-byte instruction. So in case of 3-byte instruction, it uses first byte to specify the operation, or we can say first byte is used to store the opcode, while second and third byte is used to store or specify the operand. Okay, so first byte is used to store the opcode. Okay, so this first byte is used to store the opcode, and next 2 bytes are used to store the operand. Okay, so here the operand is always either 16-bit data, or it may be a 16-bit, or it may be a 16-bit address. So it may be a 16-bit data, or it may be a 16-bit address. So 16-bit data and 16-bit address can occupy 2 bytes of memory, while the opcode can occupy 1 byte of memory. So overall, these type of instructions can occupy 3 bytes of memory. So here in this case, first location is used to store the opcode, and in the second location we can store the lower order byte. Okay, lower order byte is stored here, and the higher order byte is stored in the third location. So this is the opcode and this is the operand, and in the operand we have 16-bit data and the 16-bit address. So of the 16-bit address and the 16-bit data, lower order byte is stored here and the higher order byte is stored in the third location. For example, we have an instruction that is STA4400H. So in this instruction you can see, okay, this STA is a opcode, while this is a 16-bit address. Okay, so 1 byte is used to store this opcode, that is STA, and 2 byte is used to store this address, that is 16-bit address. So 16-bit address can use 2 bytes of memory in order to store. Second type of instruction we have is LDA4400H. So in this instruction again you can see, this is the opcode which is of 1 byte, and this is the address again which is of 2 bytes. So again this instruction can use 3 bytes of memory. Third example we have LXI D, 2000H. So in this instruction you can see, this is the 16-bit data and this is the opcode. So opcode can use 1 byte of memory, while this 16-bit data can use 2 byte of memory. So this instruction can require 3 consecutive memory locations in order to store the this instruction. So these are the different instructions according to their length. Okay students, so is there any doubt? Then you can ask, otherwise we can start with the next topic. Okay, so now we can start with the next topic, that is the addressing modes. See students, addressing mode is again very important topic. Now what is addressing mode? Anyone can tell what is addressing mode? Okay, so addressing mode means each instruction requires some data on which it has to be operate. Okay, so there are different techniques to specify the data for instructions. So these techniques are known as addressing mode. Means we have different types of mode. According to those modes we can specify the data. Okay, so we different ways from by which or by using which we can specify the data. Suppose if I want to add some data, okay, if I want to add some data with the contents of the accumulator, then there are different ways by using which we can add the data with the contents of the accumulator. First way is we have an instruction that is ADI. Suppose we have a data 20H. So this instruction means the contents of accumulator will be added with 20 and the result is stored in the accumulator. Okay. Next instruction we have to add the 20 contents into the accumulator is add B. Okay, initially we can put 20 into this register, and through this register that data will be added with the contents of accumulator and the result is stored in the A. Okay, third way is we can write the instruction that is add M. Add M means initially in this M the memory location is the address of the memory location is specified, and the microprocessor will get that data from the memory location that is pointed by this M, and that data will be added with the contents of the accumulator and the result is again stored into the accumulator. So this instruction means the contents of accumulator will be added with the contents that are pointed by this HL pair and the result is stored in the accumulator. So see students, here we are performing the same operation but there are different ways to perform the operation. Okay, so that is known as the addressing mode, means different modes by which we can apply the data in order to perform the operations. Okay, now students, we can start with first addressing mode. In 8085 we have 5 different types of addressing mode. First addressing mode is immediate addressing mode. This is immediate addressing mode. Second mode we have is direct addressing mode. Third we have is register addressing mode. Fourth addressing mode we have is indirect, or we can say register indirect addressing mode, and fifth one we have is a implied or implicit addressing mode. Okay, so these all are very important, and one question comes from this topic most of the times, or maximum times one question comes from this topic only. Okay, so we can start with the first addressing mode, that is the immediate addressing mode. So students, in case of immediate addressing mode, 8 or 16-bit data is specified in the instruction itself. So that means in these type of addressing mode, 8 or 16-bit data is specified. If it is a 8-bit, then we can say that it is a 8-bit data, or the 16-bit data is specified in these type of instructions. Okay, now you can see if in the instruction 8-bit data is specified, that means we can say that instruction is of 2 bytes, because 1 byte is used to store the opcode and 1 byte is used to store the 8-bit data. And if the 16-bit data is present in the instruction, then we can say it is a 3-byte instruction, because 1 byte is used to store the opcode while 2 bytes are used to store the 16-bit data. So either in immediate addressing mode 8-bit data is present, or either the 16-bit data is present. Okay, so first byte in this case is for opcode and second byte in this case is for the 8-bit data, and here first byte is for opcode and next 2 byte is used to store the lower order and the higher order data. Now students, we can see in case of immediate addressing mode, if I is specified in the instruction, that we can say that that instruction is of immediate addressing mode. For example, we have an instruction that is MVI A, 0AH. So in this instruction, you can see this data will be moved into the A register, or we can say this data will be moved into the accumulator. And again, second thing you can see, I is given in the instruction. So if I is specified in the instruction, then we can say that instruction is a immediate type of instruction, or that the addressing mode is a immediate addressing mode. So in this case, you can see MVI A is the opcode, while OA, that is the data. Okay, so this is a operand. So that means this 0A will be moved into A. So 1 byte is used to store this data and 1 byte is used to store this opcode. Second instruction that comes under this addressing mode is LXI H, 2000H. So in this instruction again we can see this is the opcode while this is the operand, and this is the 16-bit data. So 16-bit data can use 2 bytes of memory, while this opcode can use 1 byte of memory. So this example can occupy 3 byte of memory in order to store. Next example we can say, in case of immediate addressing mode, that is SUI 04H. So again in this instruction you can see this is a data while this is the operand, and I is specified in the instruction. That means this is the immediate instruction, and in immediate instruction data and 16-bit data and 8-bit data is given. So in this example 8-bit data is given, so we can say the addressing mode is immediate addressing mode. In this case 16-bit data is given, so we can say this is again the immediate addressing mode. In this 8-bit data is specified, so we can say again this is the example of immediate addressing mode. Okay. Now, after this, next we have is a direct addressing mode. So students, in case of direct addressing mode, the address is given in the instruction. Okay, so the address is given in the instruction. That means that instruction is having direct addressing mode. For example, LDA 2000H. So this instruction means load 2000H into the load the contents of this memory location into the accumulator. So this instruction means the contents of this memory location will be loaded into the accumulator. We cannot load 2000 into the accumulator. Why? Because 2000 is the address, and address is of 16-bit while accumulator is of 8-bit. So we cannot load 16-bit data or 16-bit address into the 8-bit register. Okay, so according to this instruction, whatever contents that are present in this memory location will be loaded into the accumulator. So in this instruction you can see 2000 is the address. So the instruction which contains the address, that instruction falls under this addressing mode, that is direct addressing mode. Second instruction we have is STA 2000H. Now in this example you can see the contents of the accumulator will be loaded into the memory location 2000H. For example, we have 04H. These contents are present in the accumulator. So while microprocessor can execute this instruction, so after execution at this location, that is at 2004 will be stored. So that means store the contents of the accumulator into the memory location that is specified here. So any of the instruction which can contain the address, that falls under this category. Now what is the advantage of this type of addressing mode is it is simple. Why? Because the address is directly given in the instruction. So these instructions are simple instructions. But what is the disadvantage of this instruction is these instructions are very large. Why these are large? Because the address is given in the instruction. So direct addressing mode type of instructions are of 3 bytes. 2 bytes are reserved to store the address, while 1 byte is used to store the opcode. So these instructions are too large while we are storing it in the memory, because in order to store the 16-bit address 2 bytes are required and 1 byte is used for opcode. So in short, these type of instructions are of 3 bytes. Okay, now after direct addressing mode, next type of instructions or next type of addressing mode we have is a register addressing mode. Now students, in case of register addressing mode, the source and the destination operands are general purpose registers. So in case of the register addressing mode, both the source as well as the destination are the registers. Okay, so basically in the instruction which contains the register where both the source as well as the destination operands are present, that we can call as a register addressing mode. So here opcode specify the operation as well as registers to be used for operation. Okay, for example, we have an instruction move D comma B. So in this instruction you can see both the source as well as the destination are registers. So if in both the source as well as the destination registers are present, so those instructions are known as a register addressing mode. So we have a registers like accumulator, we have B, C, D. So if any of the register is present, then we can say that instruction comes under the register addressing mode. Second, so in this case you can see this is the opcode and the operand is present within these registers only. Okay, now first example is move B comma B. Second example we can see move A comma B. Again in this instruction you can see move the contents of B register into the accumulator. Okay, so these are the example of this. Next we have suppose instruction XRAC. So in this instruction you can see the contents of C will be XORed with the contents that are present in the accumulator. So again in this example A is a register and C is also a register. So whatever operations we are performing among the registers, okay, and the registers are present at both the source as well as the destination, those addressing modes are known as a register addressing mode. Okay, for example we have add B. So again in this instruction you can see the contents of accumulator will be added with the contents that are present in B register and the result is stored in the accumulator. So again in this case source as well as the destination are registers only. So these instructions falls under the register addressing mode. Now students, in case of register addressing mode, the size is 1 byte. So all the register instruction that comes under the register addressing mode are of 1 byte only. Okay, so these are the 1 byte instructions. Now students, what is the advantage? What is the advantage of these type of instructions? Advantage is these instructions are the smaller instructions. These are the smaller instructions because it can occupy only 1 byte of memory. So these are the small instructions. Okay. Now what is the disadvantage of these type of instructions? These are complex instructions. Why these are complex instructions? Because we cannot know, because we don't know what is present inside B and what is present inside D. Simply we can write this command and the contents of this register will be moved to D. Okay, as a layman I don't know what is present in B and what is present in D. If I am writing this instruction directly, that means whatever contents that are present in B will be moved into D. Okay, if I am writing, suppose we have an instruction that is increment B. So I don't know what is present inside B. Only I am writing this instruction. That instruction means whatever contents present within B that we can increment by 1. So these type of instructions are complex and we don't know what is actually present inside the registers. Okay. So these type of instructions comes under the register addressing mode and the size of these instructions are of 1 byte. Now students, next instruction we have is a register indirect instructions. Okay, so register indirect instructions are the instructions reference the memory through the register pair. Okay, the memory address where the operand is located is specified by the contents of the register pair. That means address of the operand is specified by the register pair. So the operand where operand is present, that is specified by the register pair in case of the register addressing mode, register indirect addressing mode. So indirectly, microprocessor can get the data from the memory location, okay, that is pointed by the register pair. So in this case, the directly address is not given in the instruction. Indirectly, microprocessor will get the contents by checking the contents of the address from the register pair that is specified in the instruction. For example, we have a instruction that is add M. Okay, add m is the instruction. This instruction means whatever contents present in the memory location, that memory location is pointed by this m. So m is the HL pair. So if we are talking about m, that means we are talking about the HL pair. Okay, so the operand is specified within the register pair. So this instruction means the contents present in the memory location that is pointed by the HL pair, that will be added with the contents of the accumulator, and the result is finally stored into the accumulator. So this instruction, for example, we have a HL pair, and the HL pair is having address 2000H. Okay, and in accumulator we have contents 20H, and at this memory location we have contents 40H. Okay, for example. Now see, if we are writing this command, so this command, what microprocessor can do, microprocessor will initially check the contents inside this M. So what will be the contents inside this M? That is 2000. Okay, so microprocessor will jump to this memory location, and from this memory location microprocessor will get the data. So what will be the data that is present in this memory location? That is 40H. So now microprocessor will add this data with the data that is present in the accumulator, that is 20H, and the result is stored in the accumulator finally. Okay, so indirectly microprocessor can get the data according to this program. But in case of direct addressing mode, directly the address is given in the instruction. So from that direct address, microprocessor will get the data. Okay, so that is the difference between register direct and register indirect. In case of direct, the address is directly given in the instruction, while in case of register indirect, indirectly microprocessor will get the address from the memory location, that is pointed by this HL pair. So this is the register indirect addressing mode. Now students, next example we have in case of register indirect, that is LDAX B. So this instruction means, the contents of BC pair, will be loaded into the accumulator. Now you can see here whatever contents that are present in the memory location that is pointed by this BC pair will be loaded into the accumulator. For example, we have a in BC pair we have a address that is 4000H. Okay, so what microprocessor can do, microprocessor can check the contents in this memory location. So suppose in this memory location 0AH contents are present. So what microprocessor can do, microprocessor can fetch this data from this memory location, and it will add that data into the accumulator. So this instruction means whatever contents that are present in the memory location pointed by this pair, that is BC pair, will be added into the accumulator. Now here why we are talking about the pair, because X is given in the instruction. So if X is given in the instruction, that means we are talking about the pairs. Okay, so this is about the register indirect addressing mode. Now students, what is the advantage and what is the disadvantage of this? This indirect addressing mode is the most powerful and useful addressing mode. Okay, why? Because suppose how we can load, now I will give you example how to load a data into the memory location 5000. If we want to load a data into the memory location 5000, then we have two ways. Either we can do it using the direct addressing mode, or either we can do it using the indirect addressing mode. If we can do it using the direct addressing mode, then we can write LDA 5000H. So that means we can load the data from this memory location, that is 5000. And second way, if we are using indirect addressing mode, then initially what we can do, we can load the 5000 into this pair, that is BC pair. Okay, so this data will be loaded into the BC pair. Now we can write the command LDAXB LDAXB. So that means whatever contents that are pointed by this register pair will be loaded into the accumulator. So that means initially BC will be initialized with 5000 as a data. Now at this memory location 5000, suppose we have a data 20. So this 20 will be loaded into the accumulator. So there are two ways to load the data into the accumulator from this memory location. Okay, now students, why when we can use the direct and when we can use the indirect. Okay, suppose we have to load the data into 100 consecutive memory locations, 5000, then 5001, 5002, 5003, and so on. So if we are using the direct addressing mode, then again we have to write LDA 5001X. So that means after this the next data will be loaded into this. Okay, so next data will be here. Next, if we are doing, then next data is like this. Then we have to write up to 100 locations. So that means 100 instructions we have to write if we want to load the data in these 100 locations. Okay, but if we are talking about the indirect addressing mode, then what we can do, we can simply write INXB. So this instruction means initially BC pair is loaded with this 5000, then the contents of BC will be loaded into the accumulator. Then we can increment BC pair by 1. So initially that was 5000. Now if we are using this instruction, then it will be 5001. So that means again BC pair is now pointed to this memory location. Now we can load the contents of this memory location into accumulator. So using these three instructions we can apply the loop, and using loop we can load the contents into the accumulator from the next 100 consecutive locations. But here if we want to load the accumulator with the memory 100 consecutive memory locations, then we have to write the 100 lines. But while in this case there is no need to write 100 lines, we can use the loop. So later we can study this all these in detail. So this is the example, simple example. Okay students, so basically while we are using the loops, then we can use the indirect addressing mode. So this becomes easier. Next and last addressing mode is implied addressing mode. Now students, in case of implied addressing mode, the operand is inside the opcode itself. Okay, so there is no operand individually specified in case of implied addressing mode. So basically the implied type of instructions are of only 1 byte, because explicitly no data or no address is specified in the instructions. For example, CMA. So this instruction means the contents of the accumulator will be complemented. Okay, so these instructions are of 1 byte. Or it does not require any operand. The data is specified within the opcode itself. Okay, next, so for example, we have an instruction RAM. Okay, no register, no memory location, no data, no other 16-bit data or the 16-bit address is specified in these type of instructions. Next one is CMA. Okay, sorry, CMA is done. So RLA, RAL, RAR, RLC, RRC, STC. So these are the different instructions where the operand is inside the opcode only, and these instructions are 1 byte instruction, because as a operand there is nothing specified. The operand is inside the opcode only. So we have to complement the contents. Which contents we have to complement? That are present in the accumulator. We have to rotate the contents. Which contents we have to rotate? That are present in the accumulator. We have to rotate the contents to the right. What contents? That are present in the accumulator. So these type of instructions comes under the implied, or we can say implicit addressing mode. Okay, so these are the different addressing. Now students, I will give you general example. Suppose we have 3 registers, that is A, B and C, and we have to load these 3 registers with the data. 05H. Okay, so if we are using the immediate addressing mode, then what we can do, we can write MBI A comma 05H. So that means 05 will be loaded into A. Then we can write MBI B comma 05H. That means this will be loaded into B. Then we can write MBI C comma 05H. Again 05 will be loaded into C. So if we are using these three instructions, then how many bytes will be occupied? This instruction can use 2 byte. Again this instruction can use 2 byte, and this instruction can use 2 byte. So 1 byte this and 1 byte for data and 1 byte is for output. But same program, if we are writing using register addressing mode, then what we can do, initially we can write MBI A comma 05H. So initially we can load 05 into accumulator. Then we can write instruction move B comma A. So that means whatever contents present in A will be loaded into B. So what is present in A? 05. So 05 will be loaded into B also. Okay, then we can write either we can write A comma C or we can write C comma B. So one and the same thing. Okay, we can write like this also. So whatever contents present in B will be loaded into C, or whatever contents are present in A will be loaded into C. See students, why we are using the data transfer or these move instructions? So that means we are copying the contents. We are not cut and paste the contents. So that means the contents retains in this accumulator as well as these will be copied into B register. Likewise, the contents will be in the B register and the same contents will be copied into C. So that means कि B में भी contents रहेंगे and those contents will be copied into C. So if we are writing this command, so what does it mean? It means this instruction will occupy 2 byte of memory. This is the register addressing mode where operand is present inside the register. So this is of 1 byte and this is also of 1 byte. So that means if we are writing this program, then overall 4 bytes of memory will be consumed, and if we are writing like this, that means we are consuming 6 byte of memory. Okay, so again we have different way to write this command. If we are writing SUBA, so this instruction means whatever contents present in accumulator that we can subtract with the contents of accumulator. Okay, suppose we have A, B and C and we have to load this with 00H data. So what we can do, we can subtract the contents of accumulator with the contents of accumulator. So that means in A 00 is present, so 0 will be subtracted with 0 and result is 0. Okay, after writing this we can write move B comma A. So that means this 0 will be moved into B register, and then we can write move C comma A. Then this 0 is again moved into C. So that means using this instruction we can load 00 into all registers. And if we want to load 00 according to this, then we can write here 00H. Here again we are writing 00 and 00. So if we want to load 0 into ABC, then overall it will occupy 6 byte of memory. Here if we want to load 0, then it will occupy 4 byte of memory. And here if we want to load 00 according to this, then it will occupy 1, 1, 1 and the 3 byte of memory. Okay, so this is all about the addressing mode. So in short, again I will tell you and summarize you about all the addressing modes. First is the immediate addressing mode. So immediate addressing mode के case में 8-bit data or 16-bit data is present in the instruction. Okay, or second hint is if I is given in the instruction, that means that is the immediate addressing mode, and these instructions are of 2 or 3 byte. If data is given, then it is of 2 byte. If address is given, then it is of 3 byte. Next one is implied. In case of implied, no operand is explicitly specified. No operand explicit. Okay, explicitly no operand is specified. Okay, so these instructions are of 1 byte only. Next instruction we have is a direct addressing mode. So in this case 16-bit address is in the in instruction. So if the address is given in the instruction, then we can call that instruction as a direct addressing mode, and these instructions are of 3 byte. Next we have is a register indirect addressing mode. In this case, 16-bit address in register pair. Okay, so 16-bit address is in the register pair. So these instructions are always of 1 byte because no direct data is specified in the instruction. Last one we have is a register addressing mode. So here the operand is in the, or we can say the data is in the registers. Okay, so both the source as well as the destinations are register only. Again, these type of instructions are of 1 byte. So what is the example of immediate? That is ADI05H, or we can say LXI H comma 2000 H. Okay, what is the example of implied? That is STC, CMA, RAR, etc. What is direct addressing mode? LDA, यहाँ पे address, STA address. Okay, indirect addressing mode, STAXRP, LDAXRP, add M, SUBM, like this. If M is given in the instruction, that means again that instruction is of indirect. Register addressing mode like MBA, move A comma B, add C, add B, SUB, SUBB, SUBD, etc. So these instruction comes under the register addressing mode. Now students, this is the addressing mode.